All right, let's get started. All right, welcome to our second lecture. So a quick items for announcement, reminders. So this is what I generally do. So like anything that's like say something assignment coming up, due or whatever. So just make sure you check the second slide of my lecture slides. So for this one, it's easy, right? Make sure you have logged into Canvas. So you have checked out the course materials there. You know where to find what. Okay. From there, you can access Piazza, right? So Piazza is what we're going to use for our Q&A. So if you have questions, post there, and we'll try to respond soon. Okay. Lecture videos. Okay. So if you go into Canvas, the top left from the navigation bar, you should be able to see the lecture videos. Okay, so basically, I think it's generally available shortly after each lecture. Okay, so you all can just go back there and check. Okay, I checked through last Tuesdays. It was okay in terms of quality. I'm just checking quality. If you notice any issue with the recording, please let me know. Okay. Office hours, so those are all listed in the syllabus, in Canvas, and also in the lecture slides from Tuesday. Okay, so you will just check when and what time, right? Where and when the office are being offered, because as we started working our homework assignments, right? So you want to make sure you find time to one of the office hours before it's due. Okay, so just check when it's offered, so you know where to find us. Okay. Add a job waitlist. I've been getting quite a few questions regarding waitlist. I checked like just before. Seems were okay, so I hope most of you are in the section that you would like. If there's still issues, let me know. So typically what I ask students to do is that once you decide, let's say if you're in right now and you have decided to drop it, drop it sooner because there may be other people waiting. But right now it seems to be okay, but if there are any issues, let me know. I don't get to control who get add a job, but I can at least provide some information if you're anxious about getting in or leaving the course, okay? All right. Quick review of what we covered on Tuesday. That was our first lecture, just really introductory stuff, right? So hopefully you now know who I am, who I'm here talking. So a little bit about my background and why I'm teaching the data mining course. Also, some of the administrative information, just to make sure you know like how a course is being handled. We have different sections and how the grading will happen, what kind of assignments are expected for this course. So all that, okay? So make sure you review Tuesday's slides and the lecture recording. If you have any questions, of course, either send us your questions via Piazza or come to our office hours, okay? Any question at this point? We're good? All right. Okay. So today we're going to start the actual content of this course. This is the first one, Introduction to Data Mining. So every course has this introduction, but what do we learn in this introduction, right? So high level is really like why we even care about data mining, what it's about, right? What are we going to learn? What are some of the key aspects that we need to cover in this course, okay? So we'll talk about data mining, okay? Data mining, they're just two words in it, right? So starting from course, you ask about data, okay? So this really started a few decades ago, right? When we started having more of the digital data, okay? So this one we have computers, we have ways of storing data, we have ways of producing data in the digital form. So here I'm just using a few kind of examples because there's just such a variety of different types of data. But the way I generally like to think about it is that one, think about yourself. Okay, what kind of data you work with on a regular basis, okay? And then look at maybe other application domains, okay? So the ones I typically use, one, think about your daily life, okay? Of course, the digital universe consists of each one of us. If you're online or connected somehow, you have a way of like interacting with the cyberspace, right? That's a lot of digital data, okay? So one, just think about the world population, how many users are actually on the internet or connected in some way, right? So that's like 5.45 billion. That's the latest number I have, okay? Another example I want to use, this is just like think about the emails, right? I don't know how many of you are being overwhelmed by emails. I definitely have a lot more emails than what I like to handle. But that's just a rough estimate, 350 billion emails per day. All right, another domain, as I mentioned, like I work with a lot of like scientific data, right? So I'm just using some examples just to give you a sense of like the kind of data or the amount of data we're dealing with, okay? How many of you have heard the Large Hadron Collider? Maybe a few, right? So what they do, right, they basically, every time they do the experiments, they have a lot of information being collected, generated, okay? And among that information, so they're talking about 15 petabytes per year, okay? At this point, it's not a lot for a year, but this is after significant data reduction. They're only maintaining about like, I think out of that, they throw away over 90% of the data. So they're only keeping a very small amount of data, okay? That's one. Okay, the other one, this is I think I have a picture, yeah. So this is one that's like a telescope looking at the sky, okay? So every night it's trying to capture some data of the sky, okay? So that's why I say every night they're producing 20 terabytes of data, okay? So one, of course, you'll think about, okay, storage space, how do you even store that data, right? There are methods to store it, but more important is about why do you want to spend all the effort, a lot of money, right, to collect that data? Because ultimately you want to use it, okay? So as you're talking about how much data you're collecting, then you start thinking about, okay, what do I do with it? How can I keep up, right, with the data that's being generated, okay? So this is actually a little bit kind of outdated. Like, so the IDC, they actually did this digital universe report. So what they were trying to do is that you want to estimate, okay, how much data is being generated on like a regular basis, okay? So like how big is the digital universe, okay? So back in 2009, they were like, I think they estimated 0.8 zettabyte. What is zettabyte? Anybody knows? Okay, so we know megabytes nowadays, right? Megabytes doesn't seem too big, okay? What's the next one? Gigabyte? Terabyte, okay? So I hope most of you probably have storage hard drives that are maybe 1 terabyte or a couple of terabytes, right? And we just mentioned like petabyte is the next one. After petabyte, exabyte, and then zettabyte. Okay, so every time you're talking about like an order of 3,000, like 1,000, okay? So the times 1,000, you get to the next one. So it's a pretty big number, okay? But what's interesting is actually that in 2009, so the estimate that in 2009, they were like the world together was producing 0.8 zettabyte of digital data, okay? And back then, they estimate that, okay, by 2020, you would be looking at 35 zettabytes. That was a prediction, okay? And then later on, like in 2013, they say, okay, now we're looking at 4.4 zettabytes in 2013. And then the updated prediction for 2020 was 44 zettabytes, okay? They stopped doing that after 2013, so we don't have the latest estimate, but I think a few numbers, if you search online, the people are talking about like 40-something zettabytes, and then like 72 was, 70-ish was another one I found, okay? So there's no most accurate number, but just give you the scale of the kind of data we're looking at. We're looking at tens of zettabytes, okay? So you have data, so what, right? We talk about, okay, why you want to take the course, or why even, they say it's a required course I have to take it, or like, well, maybe I want to learn about this, right? So general idea is that data mining, so you want to mine something from your data, okay? So this is a bit different from gold mining, because gold mining, when you say gold mining, you know there's a gold in it, right? Data mining, you start with the data, you're trying to mine something from the data, okay? So it's more like you're giving the nugget or something, right? Starting point, as I said, like you want to start by understand your data, okay? So you don't need to memorize it, but this general idea of like, as we look at the different scale of the data, right? It's huge, okay? We spend the effort, like producing the data, we spend the effort storing the data, we spend the data effort like sharing, sending it over from one side of the network to another, right? Ultimately, it's about using it, okay? So this term is about like we're drowning in data, but starving for knowledge. So they just give you an idea about data versus knowledge, right? When you say, I have like 10 terabytes of data, how much value is it? How much you learn, how much knowledge, right, you get through that amount of data? okay? So what we're talking about is this automated analysis of massive data, okay? Guess why? Because the human attention is limited, right? We're probably okay, let's say, going through, say, hundreds of emails per day. If I'm giving you 1 million emails, 1 billion, that's probably too much, right? And also knowing that those data are not static, they're continuously being generated, right? So there's one part about, okay, how much data you can handle, but also is how quickly you can handle the data so you can keep up with the rate that the new data being generated, right? So ultimately, given this huge amount of data and the amount of data that's being continuously generated, we're talking about ways to automate the process because we want to scale up, right, with more and more data that's being generated, okay? So here, there's one thing I would like to highlight. When we say automated analysis, okay, that doesn't mean that you just put the data in some kind of machine and let it run and it spit out some information, okay? A lot of the process, right, the whole data mining process is highly interactive, meaning that there's a lot of interaction in terms of understanding the problem, understanding the data, you choosing some method to do it. The method itself as a single component may be automated, okay? But automated, like, do you want to have a fully automated, hands-off thing? Maybe? Or sometimes you want to have some knowledge, right? You know what's going on, and you do your own reasoning, okay? So that's another thing I want to really highlight for this course, okay? So if you're talking about, let's say, data mining or the job of being a data scientist, right? Data science in general, okay? What it means is that not just you just build all the tools, throw things in, you're done, okay? Because it is reasonably easy or easier to say, just to take some data, throw it into like some kind of process and have some output, okay? That's very important tools, skills you want to get, okay? But beyond that, there's a lot in terms of data mining. It's your mind, your reasoning, right? Asking the right question, finding the right types of data, finding the right tools to do the right things, and be able to interpret whatever comes out from those tools. Make sense? Okay, so as you're thinking about, like, throughout this course, think about a course project, when you're talking to people about what you do in terms of data mining, think about all this. It's your reasoning. You're telling people not just say, oh, I do A, B, C. This is what I get. Rather say, oh, this is a very interesting problem. It's challenging, so I'm trying to select this kind of data. This data has this kind of properties, so I'm using those tools, and those tools have those capabilities. And when I look at the results, I learn this to be something interesting or surprising or something, right? So that's really the whole process. So you're telling your story, right? Think about what you do, why you do it that way, okay? All right, so this really gets to some of the key aspects, okay? We're talking about data mining, okay? It's usually referred to as knowledge discovery from data, okay? So our goal, we want to get some data. We want to do something, right, with the data so we can extract useful information. That's the knowledge we're trying to find, okay? So many times we use this term interesting, okay? This is hard to define, right? Because there are so many different types of data. Sometimes or many times you don't know ahead of time what kind of patterns you may find, okay? So you will say, okay, yeah, explore the data, see what you can find, okay? So think about interesting. There are many different scenarios, okay? We all have our subjective definition of what is considered interesting, okay? But some of the general terms, right? Valid, why? Whatever pattern you find, it needs to be correct, right? So that means your process needs to be correct, your basic overall procedure will be good, your data is good, right? So it's a valid pattern, okay? The second one, previous unknown. That's important, right? Because many times you're trying to discover new knowledge, okay, instead of repeating whatever is already known. You may be validating with a new data set or new scenario. That's still contribution, okay? But generally, you're producing new knowledge, okay? Potentially useful. It's important, right? So if you find a valid pattern, it's new, but then the next question is like, why do I care, right? So sometimes you say, oh, this is a brand new thing. I don't know. Let me think about how I can make use of this knowledge. Okay? Or sometimes you already know, like going in, say, okay, I want to do better with those kind of things. So the process already kind of embedded that, not like this intention that, okay, if I can find this pattern, I know I have a way of using it. Okay, so always think about the potential use of your whatever knowledge you're finding. Okay? Ultimately understandable by human. Why is that important? Can I just have a black box that tells me whether it's going to rain or shine tomorrow? Good enough? No? Sometimes it's good enough, depending how you use it, right? But ultimately, you want to be able to understand. So a lot of this is like scientific domains or some of the like critical decision making. You not just know, okay, tell me how I like the outcome. More important is why, right? How did you come up with that like a decision? Okay, so a lot of times, like when you're looking at a method, right? You're trying to say, okay, can I have a way of explaining, right? What are my methods doing? How I explain the results I get. Okay, so you will see later on there are many different methods, and when you look at the results, think about how you can explain. Okay, so you don't want to just put up a slide or some kind of figure and say, see, this is what I get. But then the question is like comes why? Do you have some way of interpreting that result? So one keyword is interesting, okay? So like whenever you think about some kind of data mining problem setting, how you define this interesting notion of the knowledge, the pattern you're finding, okay? Huge amounts of data, as I said, right? So with data mining, you need sufficient amount of data. Okay, so I already got questions, or actually I got this question almost every year. It's like, how much data is considered sufficient? Okay, that of course varies, right? But the high level like goal is that you need to have sufficient amount of data, so whatever patterns you generated or identified is what? Generalizable, right? It's not unique to say one class. It may still be useful, but if it's too small a data set, the patterns you find may not be as useful. Okay? So a lot of times you actually want to think about how much data I need. And sometimes just like, okay, I don't get to choose. There's just a lot of data coming in, right? Think about like say like Amazon, right? If they have those transactions coming, they have all these customers, products, or you're looking at the traffic, or you're doing kind of weather monitoring, you naturally get this stream of data coming in, okay? So sometimes you say the more the merrier, because I have more data, I get to do more, right? But it takes effort, right? So for your actual process, we'll get into some of this later, especially when you're doing your actual project, right? So for your cross project, for example, like if you can, let's say, oh, if I go, like there is actually, let's say, terabytes of data available online. Do you start with the terabytes of data? Why not? Why can't I? Because apparently other data is useful. They have some valuable information. Why don't I start with the terabyte of data, the whole data set? What would be some reasoning for starting with the smaller? Computation, right? Because it may take too long, okay? So I want to start with smaller data sets, so at least to see what I'm getting. What else? How many you, when you do coding, you have no bugs, 0 bugs. The first round, you're done. Maybe? I cannot raise my hand for that one. So that's about like prototyping, debugging. Right? Because you may need a small amount just to test to make sure the process actually is correct. Okay? So usually start with a smaller data, small enough to test your pipeline, your process. Okay? When you think it's correct and reasonable, then you can expand in terms of scope. Okay? All right. So just keep those in mind. Interesting patterns. Okay? And also make sure that they have an efficient process, okay? So all this comes into play as you're trying to figure out what you want to do, how you define your problem, how you kind of identify the data sets you need, how you solve the problem and interpret your results. Okay, we'll be repeating actually many of those. As I said, like there's almost every domain with some kind of data, you can probably think about applications of data mining, okay? So here are just some kind of higher level categories that tend to have a lot of data, but by no means this is the only categories, okay? So most of you can probably easily come up with a few domains that have some kind of data that may be useful for some data mining projects, okay? So I don't want to enumerate this, but just to give you a sense of the different areas that you tend to see a lot of this data. Okay, and some of this, when you look at it, they're actually different, even though they're all, like, say, they have a lot of data in their own domains. Okay, so for example, with the science, okay, with scientific discovery, what kind of data you get? So sometimes you do experiments, right? So every time you do experiments or do your field study, you have measurements, right? You can get all kinds of data. The instruments are also getting a lot better, right? What used to be like the older instruments may not generate a lot of information nowadays. Many of them can generate a lot of data, high precision data, right? So you're actually getting a lot of data. Another thing I really like about the science domain is that a lot of data are public, okay? So if you haven't experienced this, you know how difficult it is to get data, okay? So science domain, a lot of them have a lot of public data, okay? So it's good. But the challenge is still that a lot of data have their special format, and you need to really have some good domain knowledge to be able to work with that data. Okay, so that's a lot in terms of science domain. Okay, business, that's very different. Okay, so with most of the business sector, they naturally have a lot of data, right? Because they're interacting with the customers, products, the whole pipeline, right? So there's a lot of data. Okay. And then there's a lot of interest and the value in terms of doing data mining, finding useful knowledge from the data. So there's actually a lot of support, okay? But those kind of data are not easy to get. Most of us probably don't publish our financial records online, right? Competitors, if business their competitor, I don't think they will be sharing the data anyway, okay? So it's a very different domain. Right? So when you think about those kind of data, then again, let's think about what kind of data you can leverage, what you can do with it. Okay? So last lecture we had a question about, say, you could have stock data, right? A lot of the stock price data is public. That's good. But you want to get some of the more of the private sector information, it's really hard. Okay? So if you think about any project related to business data, just be careful, right? What you can get and what you can do with it. Okay? Web, a lot of data is on the internet. Right? So earlier search engines, of course, really leverage the fact that there are so many web content that they can crawl, they can index, and then they can provide value, right, by providing the search results. Okay? That has been very successful, right? And then, of course, they're doing also a lot, using their whatever data they can collect to then provide more information, more insights. Okay? Online social network, that's also where a lot of data is public. Okay? So these are, again, different scenarios, right? A lot of data is available online. There are also limitations in terms of what you can get. Okay, so again, for your problem, for your project, right, there's a question about what data is available, what kind of data you can use, and sometimes a lot is actually about a fusion, because you may be able to take different types of data and combine them so that you may be able to answer some interesting questions. Okay? Government, okay? So a lot of actually government or agencies, they're actually pushing for this more e-government kind of thing. So they're actually making more data available, right? So in previous, if you search online, we had students, for example, using criminal data, right? Or there was some kind of healthcare and also more food programs. So there are actually a lot of information online. Okay, it's very helpful because many of those are related to either the urban cities or to your kind of general topics of public interest. Okay, but some challenges there is that those data are usually isolated to some extent. Okay. They may or may not have the best format for you to work with, and sometimes they're limited, okay? So you may be able to do actually very interesting analysis with this kind of data. Just, again, be careful what kind of data you can get and how much data you can get, okay? So all this, as you see, as you're kind of looking through these different application domains, right, you're starting to ask a little bit more detailed question, not just say, oh, there's data. You want to ask what kind of data they have, right? How much data they have? Is that sufficient for your problem, right? And what else you may be able to do to integrate things. So you're now getting to some of the specifics, because if you are the person who will solve that problem, right, you better ask more questions than just say, oh, there's the data there, I can use it, right? You'll get some of the specifics of what you can get and what you can do with it. Okay, so this really now gets into this kind of maybe one picture that hopefully covers the whole pipeline, okay? So many times when people think about data mining, right? On one side, you have data coming in. Ultimately, we want the knowledge coming out. This black box we'll be working with. What goes into this black box?
Cleaning?
I'm sorry?
Cleaning?
Cleaning, yes. Okay, so cleaning your data, because when you get your data, you don't just have it ready. A lot of times, the real world data is really messy. Takes quite a bit of effort to clean your data. What else? I'm sorry? Integration, yes. Integration, so that is usually when you have multiple data sets, right? It actually is useful for you to combine them together, but be careful when you're integrating things, because usually they're not produced thinking that it'll be integrated with another data set. So there are different ways of integrating things. Yes, what else? Data transformation, some examples? Okay, so data transformation, yeah, so the raw data format may or may not be the kind of format you're working with. Okay, so you probably need to do some transformation, okay? Very simple example, you may have, I don't know, like there's very simple coding things, right? Text data or different categories, you code it into like some kind of numerical information. Creating a requirements document. Can you be more specific? What kind of requirements?
Like the user requirements, what the user wants from the data.
User requirement, but you're not talking about just access control though. So requirements, okay, maybe I will just take that a little and change a little bit, some kind of metadata, okay? So the idea is that you have the raw data, right? And as you're understanding the usage scenario, the problem setting, this could be related to the users or could it be related to the data itself, right? So some of the metadata or some of the, this could be like a scenario where say, okay, I'm just producing data. So I'm producing the data, I provide enough information so others can use it. I don't care who is going to use it, what it's going to be used for, versus I'm the kind of the end side. I want particular types of data, right? So I want to make sure I'm getting the right type of data. What else? Yes?
Modeling or visualization.
Modeling, yes, right. When you have the data, after cleaning, after integration transformation, you need a way of actually doing something, right? So that the modeling process is actually taking the prepared data, do something, right? So that you can find some interesting patterns. So we talk about similarity, dissimilarity, and maybe some way of predicting what may happen. Yes. Anything else? Visualization, yes. So a lot of that times with the data mining, visualization is very helpful, right? This could be happening along the process, not just say when you have the results, right? You may actually be visualizing your raw data or the transformed data or whatever model results. There was another hand. Statistical analysis, this is about understanding your data, right? So you got the data, right? You want to understand your data before you do something, right? So try to characterize your data so you have a better sense of what kind of data you're dealing with. Okay, we have, yes? Evaluation, yes. That's very important because as a seller, you don't just create the results, right? Say, I'm done. Take this and trust me, it is correct. You need some evaluation to show and convince people and demonstrate to yourself that this is indeed correct, right? Okay, so take all this together. So the data modeling, that's actually something people jump in quickly. You say, like, oh, I have data. I know what I'm trying to generate. So I just throw it into data modeling and get it done. But as I said, right, the class actually already, we collectively identified quite a few things that you need to handle, right? Not just the modeling itself, okay? Starting point, where do you even get the data, right? The data is not just sitting on the hard drive that you just go and use it. Many times you need to figure out where to get the data. Right, in that process, understanding what kind of properties is already there, and like what you need to be able to interpret the data you have, right? And the general understanding, statistical analysis, something you can do at this point, but then other things. This is about preparing, right? So you have the raw data. Now you do your first round of kind of processing. This is usually referred to as pre-processing. It's about getting your data usable. right? So there's a lot of like cleaning, integration, transformation. Those are all important things you need to think about, okay? Sometimes you may say, oh, I really don't need a cleaning because I already prepped. That's fine, but actually at least justify and actually validate to yourself. This is indeed clean data, right? Because many times you don't know what kind of data you have, right? And then the data warehouse is somewhere in between the modeling and all this pre-processing. Or actually, sometimes you can integrate the data warehouse and do all that. Okay, so data warehousing is important because that you can view that as a way it's going to getting the data ready for the modeling. Okay, so you'll be like bringing in very different types of data. They have very different characteristics. So as you're like trying to prep, right? Prep your data for individual tasks. Right? There's a lot that the data warehousing step will do, okay? And of course, modeling. There's a lot you can do in the modeling like process, right? It's generally just like you have data, either say, okay, I don't know what I'm going to find, so I just want to try different modeling technologies and see what I can find. Or you have a more particular problem you want to do, so you kind of know what kind of modeling you need to do, but then still there are many different techniques you may be able to use, okay? And then evaluation. Okay, so ideally, when you go through all this, ultimately, right, you take from the raw data, go all the way, then you have knowledge. But usually it's not that simple, okay? It's not easy to get it right the first time. So there's a lot of kind of iterative process. Sorry, have to go back to the previous step, do more, right? So many times, just think about this is like the overall process, right? You try to reason about each step, what you can do, why you want to do it this way, and if you get this, is it good enough to go to the next one? But a lot of times, it is an iterative process, because with data mining, the interesting but also challenging part is that you don't know what you find, right? So you want to be able to say, okay, I want to do all this, right? This is what I intend to do, okay? But there's a lot of reasoning, okay? Goes into this process so that you know, like, at each step, right? You talk about, okay, why I'm doing this way, is it good enough, right? Or do I need to change something, either in this step or go back to the previous step or previous two steps, okay? Just keep that in mind, okay? Looks simple, but a lot really goes into this process, okay? So that's why I say, when people ask like, what are you doing data mining? Think about the whole black box, right? This is all the things we do inside it. And it's really not as simple as just throw the data into some like black box and have it spit out some like model result for you. Okay. So now we say, okay, we kind of know what we need to do, right, in terms of pipeline. But every data mining project is different, right? For our class, like, that's why I'm looking forward to see your course projects, because it'll be very interesting. Every year we have a wide variety of projects. Now think about either you're trying to define your own project, data mining project, or you're trying to learn from somebody else, right, what they work on for their data mining project, okay? So there are a few things to ask, okay? So these are called different views, okay? So there are different perspectives when you're trying to look at a data mining project, and all those in combination, that is how you can define or understand a project, okay? So as you're thinking about data, of course, right? You need data to start with, okay? So what kind of data you're using? That's one, right? And then say what you're trying to learn. That's the knowledge, right? Okay? And that usually will be connected with your application, because whatever you're learning, right, you will think about the usage, right, in a particular application scenario or multiple scenarios. But you want to have something in mind. But then, more importantly, method, right? You define, you say, this is the data, this is what I'm trying to do, and this is how I'm going to use it for some application. Now, do it. That's the method, okay? So as you're kind of thinking about your course project or you're learning about some others project, right? Ask those questions. These are the 4, okay? So let's do a little bit of practice, okay? Let's just here, we'll get into some of the details, okay? But just starting point. Anybody want to start with one? Say if you're trying to define your project. Let's see what we can do with these 4 ways to characterize your project. Anybody? Come on, this is not a test. Great. Yes? Okay.
Then methods would be, I guess, there are some models on the or CE projects, like I don't remember now, but like on the basis of that, you can detect the stabbing procedure or like the movement of
Sorry,
the
I didn't. No, it's okay. So we can do a little bit practice here. Okay, I should have had this prepared. Okay, so data. What kind of data?
So you'll get a video data of people stabbing, or there is some a chaos going around where people are fighting with one another. So the
So
type
video
of
data is coming from your CCTV, right?
Yeah,
Surveillance
CCTV.
cameras. So you
Yeah.
probably know how many cameras, how often you're getting those, so what kind of coverage they have. This
Yeah.
is just a little more about the data.
Yes.
Okay. And then what you're trying to find, knowledge.
So the knowledge, I guess I'm guessing, like it would be stabbing, like there would be an alarm or something that needs to be raised. So the knowledge would basically be the process of stabbing or fighting.
Okay.
And the application, or like the after stabbing there is something anomaly that needs to be get alarmed, or something alarm clock that needs to be raised for police or someone in order to address
Okay.
that.
So the anomaly what you're saying is the stabbing or maybe more generally attack or some
Yeah.
fight
Yeah.
scenario. So you think about the surveillance cameras, right? You'll be monitoring things going on, but there'll be anomalies particular to some kind of like criminal
Yeah.
activities, right? Application, as you're saying, like this is for safety, the police officer may be able to use it. This also get a little bit actually of the latency angle. Is this more for post-processing, finding something that happened before, or sometimes it can even be a bit of more alert mechanism depending how things are happening, right?
Yeah.
So you can think about, so that's why from the application point of view, you may be able to define, do I need to do this in a more efficient fashion, meaning that low latency, versus this more for post-processing. I have a lot of video coming in. I want to be able to scale, like say, high throughput processing. So that actually application may give you a better sense of what you're trying to do.
Yeah.
Method?
Maybe at first is you need to get the frames of the video. Once you capture the frames, you need to detect a human, like human positions of the arms and stuff, like how exactly is the movement. Then you need to track the movement of all the hands and how many people are there in that video frame. So you can get a time frame, even like in the video itself, it is a time frame series where you're tracking the movement of your hands and what exactly positions are of the people. And you need to add a model or something that would do the analysis of, like you need to pre-train a model. It needs to be, I guess, supervised first. And on the basis of that, you can predict the results.
Okay, all right, very good. Yeah, so videos, like you naturally get to some of the frame, like the segments, how you identify. But in this case, I say supervisor versus unsupervised, we'll get it later. Because if you're looking for a very specific action, right?
Yeah.
But even that, like the background can be very different. The body, like positions of the people can be very different, right? That actually makes this all hard, okay? Even the stabbing, the weapons that are being used may be different. So that's why from the technical side, the method of view is challenging, right? So you can also decide, for my problem setting, can I use a supervised learning method because I expect I have good labeled data to use, or no, it's challenging. I want this to be generalized into more diverse settings. Then sometimes you want to consider unsupervised because you don't want to rely on very specific labels, or can be semi-supervised. So this actually gets to when you're reasoning about your method, right? Understand the challenges, like what kind of things you're dealing with, but also what will be needed, right, for your particular application. So, but all those are good, points to consider. Thank you. Very good example. Anybody else want to try? Oh, wow, a few hands. I'll go to this side.
Thank you. So I was thinking about job market analysis through
Okay,
LinkedIn
job
data,
market.
or are there any other job portals. So the data would be textual data. So we could analyze the sentiment.
Sorry, what kind of data?
Textual data, text.
What?
Link post.
Okay.
LinkedIn
All right.
data. Yeah.
Okay.
So the
How
data
big
would
is the
be.
data set? How many people? How many jobs? Do you have any sense?
It could be we could. we could cut short it to maybe a specific, like maybe software related field, and then we can maybe even further filter it to a particular domain like finance or healthcare. We could cut
And also,
it short.
depending on what you're looking for, you can look at more of the longer time duration. For example, historical data, like during the past 5 years, or you care more about the latest, let's say this year or the past year.
We could consider a part of historical data, maybe 1 year and the current year data, because we can have a better pattern seeing how whether there's an increase in job availability or
Yeah, maybe. So that's
Yes.
the reason you want to do, like what
Yes.
kind of data you want to use and how much data you want to choose and why you're only picking those particular data. Yeah.
And the knowledge view would the type of knowledge that would be discovered would mostly be the insights. For example, the current situation in, let's say, in financial sector. If there's any job application, like the job openings and what kind of job openings are there, maybe related to finance analyst or business analyst, something like that. And the method view.
Check it. Can people in the back hear okay? I feel the microphone is a little bit low. Is it fine? Oh, okay. All right. Yeah, please
Right.
continue.
And the method view would be types of techniques utilized. We could understand a pattern based on the number of jobs that have been enrolled, something like that,
Okay.
in every month.
So there's quite a bit of statistical analysis.
Yes.
Yeah.
We could start with the descriptive and then move on to inferential. Maybe just get an idea on predicting. We can't exactly predict, but just a rough overview.
Okay.
We could get that using inferential statistics just to understand whether the data which we're getting is actually right or wrong. That is one thing. So that is about the method view. And the application view would types of...
Like, do you expect this would be used by, say, HR, the hiring side,
Yes.
or the actual, let's say, each of us who are
It
looking
could
for
be
a job?
used in multiple ways. The HR could use it to understand if there are any, to see competition. Maybe if you target again within financial sector, you can look into multiple companies and see how they track their employee records. I mean records as in like number of people who have laid
Okay.
off or hired, interns hired, freshers hired, senior developers, something like that. And the other perspective is with respect to students who can see which sector has a better, the student has a better opportunity to look into. I mean, being a software engineer, you can look into multiple sectors, nothing like financial, healthcare, there's a lot more. So I think that would be an application.
This probably goes back to the data questions about like why you're looking at just from last year to this year. Sometimes the historical data can be quite useful because there's a bit of cycle or there'll be more dynamics to the job market. So those information also be very useful. But anyway, yeah, very good example. Thank you. All right, I hope that now gets you started. I say this is just a practice I want you to really just start working on. So as you think about your project or thinking about like discussing with people the project, those are the things, right? Use those 4 views to guide your discussion, okay? Because you want to have all those, and they need to come together so that you have an interesting project, okay? So now let's get to some of the specifics, okay? Now we just get into practice, right? Data view, describe your data. What kind of data do you have, right? I don't know how many of you have heard this, V's. Some of you maybe, 3 V's, 4 V's, 5 V's, okay? So many times when people talk about data, right? Our example earlier is the volume. How big is the data set? How much data you can get, right? So that's the first V, okay? Now given the first V, what are the other V's that may come? Like, it doesn't have to be V, but like what other properties of data that come to your mind? Somebody? Variety. They're just different types of data, right? Okay, so that's about like what kind of data you have. We're using V just to make it consistent, but generally just say, okay, there are different types of data. What else? Velocity, okay? The term basically says change, right? So at the earlier days of the data mining, we tend to get a snapshot of the data and spend a lot of time doing the analysis, and our pattern will be then like based on that particular snapshot we get, okay? But nowadays, for most of the areas when you're collecting data, you're getting data continuously or periodically, right? So you're not talking about just say one snapshot data. You actually want to see changes, right? The job market, or like example we mentioned earlier, right? Or stock market, traffic, weather, all those can change quickly, right? So a lot of that is about how quickly things are changing, how quickly data come in, how quickly you can handle your data. So that's all goes back to the question about whatever solution you come up with, you need to be able to keep up with the problem and the data, right? Okay, so these are the initial 3 V's when people like started talking about the data mining, big data, okay? There were like 2 other V's people kind of added later on. I'll just add, this is about veracity. Okay, so this term generally just refers to the quality of the data, right? It's like you don't make assumptions, okay, I have, say, petabytes of data. I know they have like 4 different types of data, and they're coming, say, like every minute. That's good. But a veracity basis says, okay, you have this data, but are they good quality, right? So there are, of course, different ways of measuring quality, but generally you want to make sure that the data is what you can use. So this also goes back to the earlier question about the cleaning, pre-processing, so that your data is of usable form, okay? The 5th one is different in terms that like, it's also a way to characterize, right, how valuable your data is. But that is, again, a term is dependent on what you can do with it, right? Many times you don't just put a price tag on the data and say, okay, this is how I'm going to say it. But you want to understand the value, because if the values are high, you may be able to ask for a higher price, right? But if you cannot do much with your data, then it's not much value. So a lot of times when we put all this together, just when you think about the data, think about the value or potential value, right? For example, I say, if I'm just collecting information about, let me give you an example. We did this project, like air quality. Okay, we're measuring air quality. Okay, we have people like just putting some kind of sensor on their arms or in their backpack. So whenever they go, they're collecting data about the air quality in the particular indoor spaces. Okay, so there are definitely like issues about the characteristics in terms of volume, variety, and velocity. Veracity is very important because we want to check the data is good, right? The sensors are miniature sensors, so they're not those high-end, expensive sensors. So knowing how precise the measurements are is important. But then when you think about the value, right? Why do people care? Healthcare, right? It's air quality. It's my personal space, right? So from the individual person's point of view, I actually like to know, like, if I'm in an environment, how good the quality is. So people pay for those kind of sensors or those kind of knowledge, right? But then from the facilities, like the management side, they want to know, right, which indoor spaces have maybe not so good air quality, or there may be some instance, and like there may be some acute scenarios that there's some kind of air pollution happening, right? So there's also this kind of general facility management, safety, and actually planning perspectives to it, okay? So think about how you can use, make the data valuable. Okay, there's another way, right? So we talk about those V's, and you can just generally look at what kind of data, where the data come from, right? So earlier days, there's a lot of kind of database-oriented data. Right, nowadays, maybe not all the data are from the database, but earlier days, really the database community was driving a lot of the data mining research. Because when you have a way of managing the data in the database, right, typically we talk about relational database, right? So you have a way of managing your records, knowing that you have all these different columns, like related information. For example, our student database. Think about each of you have an entry or multiple entries in the campus-wide database, right? Because we have the information about individual personal information, which courses you're taking, which degree program you're in, and all that, right? So that's the information you get. And many times you do get data in that kind of format, okay? But later on we have data warehouse, NoSQL is another one, but they're just different ways of managing data. So this is more like, say, where the data are managed, how they're managed, that actually may impact, right, the kind of data you get. And then there are other types of data, right? Sequence, stream, temporal, time series data. These all have this notion about some kind of order, right? Sequence, they don't have the notion of time, but there's an order, okay? And then naturally, when you have this streaming data, that just means it is continuous, right? And because it's continuous, you have time naturally associated with it, okay? Spatial, temporal, that's another one we have mentioned, right? So look at like what kind of information. So that's to say earlier, say if you're using the surveillance camera, I'm asking about the coverage, right? So the spatial relation is important because some camera, depending on how they're positioned, you may be able to combine them to have a better view of the scenario. Or just say, okay, I don't have enough coverage in certain areas, okay? So that's all important. And then text data, multimedia data, when you go to the web, there's all kinds of rich media data, okay? So those are very different from the numerical, maybe the readings from the sensors, right? Graph, social networks, so that's another way of organizing the types of data, right? So this is, again, very different from simple time series data, right? So they're just different types of data, okay, as you're working with your data. Knowledge, this of course we're going to spend a lot of time on, okay? So there are many different things you can learn from the data, okay? So we have a few different high level summaries here. First one, concept, class. As I said, right? A lot of times with data, you want to be able to just say, okay, you want to characterize your data, okay? Characterize by identifying some properties that is common for your data set, okay? So for example, if I take my class, right, the whole class in my data mining course, okay, what do I find in common? I can probably do something maybe about age group. I can probably do something about gender, right? I can also describe maybe in terms of which major you're coming, right? So it's just about a way of characterize your particular data sets, okay? And then with that characterization, then you naturally get to the next step because I have a group here, I have a group here. How do I differentiate things? How they're different, right? Okay, so I mean, have my data mining course. If I'm comparing with, I don't know, like maybe another course that I'm teaching or my colleagues are teaching, don't say, okay, how are they different, right? Or if you're talking about customers, that's another thing. That's the finance sector is doing all the time, right? How come these customers purchase, they go to this store but not to the other store? What's different, right? What are the driving differences? So you're trying to characterize the different groups and then compare, right? So you have a way of saying, okay, why like they are in this group versus the other group. And then so with the basic characterization and differentiation, and then we're looking for frequent patterns, right? Frequent pattern, as the name suggests, just something that happens frequently in your data set, okay? So if you're talking about transportation, right? Sometimes there's always a traffic jam. Isn't today there's a football game? Anybody's going? So if you want to look at the traffic pattern, you probably know, like, well, whenever there's something happening, it's going to be congested somewhere, right? So those are the kind of things you can identify because it happens frequently. So there's a way of defining frequency, okay? How frequent do you see things? But then even those patterns, depending on the types of data, it can be different. First one we call it frequent item sets. Okay, so think about like certain things you buy together. So they're always in a set, in a group, right? Or I say a few friends, they always go to things together, right? Again, that's the frequent occurrence, but they occur as a set, okay? But then if you have some kind of sequential information, you can look at sequences, order, right? So if you think about your like daily routines, or like say every time after maybe the data mining course, you go somewhere, or every time like before dinner, you do something, right? So those kind of frequency is actually very helpful if you're trying to predict things, right? Because now you have this knowledge that say, okay, this is likely to happen, okay? So that's sequence. What about when you have some kind of graph data? Now you talk about structures, right? So it's not about this one-dimensional order of something happen frequently. Now you say, okay, certain structures are actually frequent, okay? So usually in the group setting, you could say, like you may have this star-shaped connection. So that means there's one node or one person who is like the leader, and he's the person talking to everybody. But then those members, they don't talk to each other. That's a star shape, right? Or you can have some kind of hierarchical structure. So like you're somewhere in the hierarchy and then you only talk to the people above or like below you, okay? Or you can have a full mesh. That's everybody's talking to everybody. Great, right? So as you can see, right? So those are all graph structure, but you're looking for patterns, right? That's just frequent in your data set, okay? So beyond the frequent patterns, then we'll be talking about some of the associations, okay? So what the association basically says that is just like if this happens, like I say A and B, they happen frequently together, okay? Now you're talking about, okay, if A happens, how likely B would happen? Okay, think about Amazon recommendations. Some of you may have noticed this, right? People who bought this also buy that, right? Okay, so now you actually have some knowledge you can play with. If there's a high association, so that means like it's likely to happen, right? More likely to happen than the other. Then you have a way of making recommendations or predicting things, right? So you can even provide some kind of incentives so to boost the purchase or the transaction, okay? So we're kind of like not getting into the details of like support confidence, but at high level, it's about the probability of things happening together or the conditional probability of something happened, what's the likelihood of the other thing happen, okay? Classification, okay? So this gets to the part about differentiating things, right? Earlier we said, okay, you are able to characterize different groups and they have a way of separating things. And once you have a way of separating things, you can classify them, right? So the easiest way or simple way would be the binary classification, right? A yes or no scenario, okay? So I'm trying to classify whether the customer is going to purchase something, whether it's going to rain or not. So those are all binary classification, right? But many times it's like a more diverse, right? You may have multiple classes, right? So if you say like people like different types of movies or sports or some activities, right? So your classification may be related to, okay, based on certain attributes, right, of those users, you have a way saying that, okay, they are more likely in this group. They are more likely in this group, okay? So again, those information can be leveraged because if you have a good way of a strong classify or accurate classify, then you can leverage that information for some real-world application scenarios. Related to classification is prediction, okay? So classification usually have a few categories, right? You're just trying to decide a category 1, 2, 3, 4. Prediction is that, for example, I'm trying to predict the amount of precipitation we're going to get. Or I'm trying to predict the annual income for the job market, for particular types of job, right? Or I'm trying to predict your like the performance of something. So you basically talk about a continuous like numerical range. So in this case, it's not categories. You have too many categories to put them in, right? So your goal is not to precisely predict, right? It's say 0.05, okay? Rather, it's okay. I want to predict something. I will say how close it is to the actual value, right? So now it's not about like classifying into the correct category. Rather say I'm predicting that is close to the actual value. So stock price prediction, right? Or predicting traffic volume, predicting how many people show up for today's game, right? All those things, right? So it's about the numerical measure. All right, class analysis. This gets to the supervised versus unsupervised, okay? So we're talking more about the terminology, but with classification, you kind of already defined your classes, right? So you have those labels of those classes, okay? While with class analysis, this is general idea, say, I don't know. I have a data set with certain data points, okay? I don't have predefined categories. I don't even know how many classes I have. Instead, I'm just trying to play with my data and see whether there's some natural grouping. Okay? So that's the unsupervised idea. It's like, I don't know ahead of time what I'm trying to find. But based on the property of the data, I'm trying to look at the similarity, dissimilarity, so I have some way of putting them into different groups. Okay? So that is about clusters. All right? Deep learning, this is a term that's very active. This is not by itself a knowledge itself. Okay? It's just a method or a type of approach that people are using. So we'll be talking about that further in the course. But at a high level, it's basically trying to use this kind of a neural network structure, okay? Trying to capture a lot of information, but by weighting them differently and how they combine so that you have a way of taking from the raw data, right, through all kinds of, integration, weighted integration of the information, and then manipulation of the information so that you have a way of deciding on some output, okay? We're not covering the technical details yet, but at a high level, I want to say there's actually a lot of applications. It's a very active field. Most of you probably have heard that in many different settings. It's very active. It's being shown to be successful in many applications. And why we're talking about this in the data mining course, because even though we're not doing research or we're not focused on how the specific deep learning methods work, they actually have enabled and changed a lot of the things that we do in data mining. So we'll be coming from that angle in terms of how this can be useful for our data mining purposes. Okay? Another one, outlier, we mentioned that earlier, anomaly, right? So earlier we're saying that we want to find things that are similar or things that are different, right? But this is in a more like a still like common, like a general setting, right? You may have different groups, but they are still equally or like a still big size. Outliers are just say, they're just like the minority, they're different, but we want to find it. Why? So outliers can be something that's just error. You want to throw it out. But still important to know that your data set has outliers that should be ignored. Because if you don't do that, that may skew your analysis significantly. So that's one part, right? It's different, should be ignored, but I want to find it anyway. But many times, anomalies are actually significant events. Okay? So the stabbing thing, fraud, transaction fraud, that's also many important things. Medical diagnosis, sometimes you're finding this, that disease is actually is anomaly out of many kind of normal settings, right? All these actually are significant scenarios, okay? So you want to identify them as different, okay? So that you can decide whether this is something that's, okay, I know what it is, I just ignore it, versus, oh, this is something I know, but it's significant, we should investigate further, or say, we've never seen this before, let's do more investigation, okay? So my example here, this is actually some like remote sensing data. You don't need to get the detail, but when you visualize it, there's again example of a visualization, the power of visualization. If you're just reading the data, this long columns of data, you don't see much. But when you plot it, and when you actually know what you're looking at, then you will see there's some significant change, right? So you have this kind of like periodical pattern, you have some of the spikes that is occasional, but then you have this big shift, okay? So this is just a way to show that the anomalies can be very different. Nobody knows upfront what kind of anomalies you will see, okay? So there's a lot in terms of defining or finding things that is normal. Because if you have a way of defining anything above 100, anything below 30 is anomaly, fine, you can do that in a general sense, right? But there may still be scenarios that is contextualized. So you need to understand the problem setting, understand your data, and then have some specific mechanism to be able to pull out those things that just look different from others, okay? All right, there's one more, yeah. So trend evolution, this also related, that's kind of knowledge. So, because many times I said that when you have continuous data or data that is like coming in a kind of periodical fashion, or even just it's not periodical, you have but a sequence of data, right? So naturally you're asking this question about, will the pattern change, right? Or do you see changes over the years, right? Think about the job market example, right? Is every year you kind of see similar things, or there's some fluctuation, or there's a particular trend going up or down, right? All those are important information. And with that, you can think about evolution, right? How things are changing, okay? How many of you have played with the Google Trends? A few? No? A few. Okay, let me see how much time I have. I have a little bit of time. So let's try to play this a little bit. Okay, so Google Trends, this is basically they're using the search terms, right? Every time you type in a search keyword, right, they have information about who's searching what time, from where. Sometimes they have regional information. So here, for example, right, so this is what the United States is searching for right now. So apparently it's like a temporal graph, right? It's showing how things are changing. So your x-axis is the time, some time scale, okay? And then the y-axis is showing something that's fluctuating, right? Okay. A lot of things are happening. Let me see. So let's explore. Anybody want to choose a word that we can play with?
Prime time.
Prime time? Something happening that I don't know. This one? Okay. So interest over time. So first you need to learn, right, how you interpret this, okay? As I said, like, so this is showing the time duration. Okay, so this is a past day, and then I think this, I think they don't show the exact, it's all relative, but like basically you get a sense of like whether, how much fluctuation. Is this what you're expecting, or do you?
The daily's kind of hard to tell.
Okay, so choose to maybe a year. Okay, all right. Why? Well, it makes sense.
It's Dion's like, you know what I'm saying? That's like right around playoffs.
This one? Okay. See? All right. So we're not getting into detail, but as you can see, right, this already gets us either when you're doing the search term, you may have some idea, right, where you may see changes. Okay? Sometimes you don't know, you just do search. But as you can see, this is actually very interesting, like a simple but interesting tool. If you have the data, the underlying data is basically just the search terms, right? But then you have a way of plotting it, right, over time, and then you can choose the different like time periods, right? They actually do categories, and you can also do region, I think, yeah. So there's a different region you can use. And then let's try something. Think of something that's periodical. Can you think about? I'll probably use one already. This is not the best one, but I'm probably getting this. Let me change it to. Okay. So this one just says a general periodical, but you see some spikes. Those are the years when something is particularly bad. Okay. Or worse than other years. Okay. Another one. So I work on electrified transportation, so I want to actually show this one. Or just electrical vehicles, that's probably easier. Vehicle. I'll just do that. Okay. So this one, as you can see, right, there's some fluctuation, but let's say overall there's a trend going up, but then there's quite a bit of dip recently, okay, or in the previous year. So this is another thing, right? You can see this upward trend generally, but then you see things are happening. Anything else people want to try? Another one? Something that is on your mind? Of course, you can play this by yourself. Okay, it's a simple interface, but really, like, it's actually quite interesting to see. Actually, let me see what I can bring up. They used to have more like a region one. Looks like this is more by country. It may be harder. So if you want to do kind of, yeah, so regional, oh, one thing just happened, right? Olympics. That's probably easy. It's being a bit of slow. Oh, what I'm doing. Here. Because the Summer Olympics finished, and that was yesterday. The Paralympics just started, so there's, of course, you expect to see some spike, but this will actually see there's actually quite a bit of regular, because it happens like every 4 years, but of course this one's off because of the COVID, right? So that's what I say, when you're looking at this is just, you want to get into the habit of one, understanding what is underlying, right? What kind of data they're using, okay? And then like in terms of knowledge, right? Either this is something you kind of expect, want to just verify, or you don't know, you want to see, but then when you see the results, you have some way of interpreting. Because you don't just take it as is, right? Because when you see this, okay, yeah, is that expected or unexpected, right? And if it's unexpected or something that looks different, and then you have a way of diving deeper to understand it, okay? All right, going back. Make sure I'm still. All right. So here, just a few more examples. This is more from the application side, right? We market analysis, we actually be using that example quite a bit because in the market, there's just a lot of data and a lot of motivations for like doing data mining, okay? So I said that from the market side, there's a lot of data. They have a lot of data about their customers, a lot of data about the products, about their like overall process, even the supply chain, club cards, customer calls. So all this, right? A lot of information. Right? Some of those are public, but I said like many times if it's more like like a private sectors, then it's actually harder to get data. But if you work for those companies, then actually you may have access to a good amount of data. Okay, so application, right? So I have all this kind of data. Some of the key questions, or can really kind of say, like there's a lot of investment and a lot of like need for this is that better understanding of who buys what, right? Because in the market it's about selling products, right? So if you can figure out, right, what sells better, what kind of customers tend to buy what, that can really be very useful, right? So a lot of that is about characterizing your customers or be able to do some kind of classification or clustering, identify different groups of products or different groups of customers, or if you can look at some kind of temporal changes, across a lot of kind of seasonal changes, right? People tend to buy different things. There's also spatial variation. Some people in certain areas, they like certain things versus in another area, they have different things. So there's all this actually comes into play, right? Spatial, temporal, right? And also the different like categories. You may have numerical information. You may have some kind of like a video or some like graph information because of how they're connected, all that kind of things, okay? And of course, what factors attract new customers, right? This is about like developing your business, right? Instead of keeping or predicting your current customers, now you have new customers. That's actually challenging because you don't have a lot of information about new customers. So what you're trying to learn is whatever you have learned from your previous customers, other ones, right? And then trying to apply to something or adapt to the new information. Marketing, targeted marketing, right? Product recommendation, discount, all those are, again, like by knowing what your customers are interested in, right, then you can provide incentives, okay? Instead of a general recommendation, now it's targeted, right, to individuals because you know at this point what they may be interested in buying. Fraud. Fraud is on anomaly side, right? So that's why I say from the application side, when you talk about anomaly detection, then for your problem setting, say, okay, do I need it like by the minute, okay? Or it's okay, I get it within a day, right? So those all are driven by your actual application scenarios. So we get to some of the discussion. We actually talk this a little bit more, so maybe we'll go faster, right? So interesting patterns. Always think about whatever you're looking for, right? Why it's interesting, why it's worth your time, effort, okay? Sometimes you may have objective measures. That's great, right? Accuracy, false positive, false negative, or running time, throughput, all those are good, right? But a lot of times it's subjective. Sorry, we don't make it easy, right? So depending on your actual usage scenario, different people, different experts, right, customers, they may think differently. So then you need to, again, understand the usage scenario, understand like the what like your customers, like what is the intended usage scenario, and then what kind of measures are most important. Okay, a lot of times it's about completeness versus exclusiveness, because given the same data set, you go in, you find something, you're done. This is like finding gold, right? In like gold mining. So how do you know you have found all the gold in that area, right? So some method actually can tell you, right? If you run this process, I'm guaranteed that you will find it, everything related to this particular criteria. Versus something just like, no, I cannot guarantee, but I can provide some kind of high probability. So that's the difference, right? So that's also very important to keep in mind as you're talking about it. Okay, major issues, right? So why do we, like we say, we care about data mining, but what are we going to study in this area? Of course, a lot is about technology, but what about the technology? There are different kinds of knowledge we're trying to learn. We have very different types of data we're trying to learn, so apparently the methods cannot be the same, right? You need different methods for different scenarios, okay? Evaluation, how you evaluate it. Because you have a method, you have the corresponding measure, right, to show whether it's useful. efficiency, effectiveness, scalability. Those are things we continue to talking about. Also, like nowadays, since they have more of the continuous data and the larger scales, a lot in terms of like parallel processing, distributed processing, incremental, we'll get to that later as well, okay? How you use the background knowledge. Skip some of the specifics, but so technology one side, but a lot is about the user, right? Because ultimately you want to interact with the users to kind of show what you have learned, but also in terms of learning more from the user so that they can provide feedback. So there's a lot in terms of how you interact with the user, and of course application. I have time, I will just show this one slide before I have to let you go. This is about ethics, okay? So as you're talking about the data, and talking about what you want to do with the data, think about the impact. Is the data private? Is the data sensitive? Do you have the right to use the data and disclose what you have learned from the data? What are you doing? And whatever you learn from data, what's the implication? If I'm using, say, this class, I'm trying to generalize, like based on your gender, based on your age, I'm going to predict your grade. That's probably not the right way to do it, right? So think about the impact. So whatever you're learning, whatever you're using, there's some impact, right, for the actual use, okay? So with that, we're going to stop here, and we'll continue next Tuesday. Ooh. Hi.
Hey, how's it going?
Good.
Question for you.
Uh-huh.
I was wondering if we could get the lectures like just before the class, so I could take